do you pick? Head or tail? Head or tail? Head? Tail. So you get to decide you want to be team A or team B? Team A. Okay, good. So team A,中兴 University. Team B, Nanjing University.
Greetings, I'm Zheng Qingwen from National Zhongxin University, and today I'm going to report our study of boiled egg. And let's make a brief review about the topic. It says that suggest non-invasive method to take the maturity of a boiled egg, and we have to investigate the sensitivity of our method. So, in the following report, I will divide my experiment into 3 parts. We use 3 different properties to do the experiment. And the first one is physical properties like density. And then the mechanical properties like moment of inertia, and optical properties like absorption spectrum. And then we will get into the conclusion about the sensitivity. So before we start talk about our experiment, we have to give a clear definition of maturity. And we define that when the egg boils in 100 degrees for n minutes, we call it n minutes maturity. And this is a different maturity of egg. And you can see the egg start to denaturalize during the boiling. And in the experiment, we use the rope to wrap the egg and hang in the water to boil it, so the heat can be average heated. And then the definition of the sensitivity. And the sensitivity means that the ratio between independent variable and dependent variable, and it can be expressed like the delta y over delta x. And to make it more clearly, for example, we given x squared equals to z and x equals to y, and the sensitivity, we will get that x and y sensitivity will bigger than x and z sensitivity will be bigger than x and y. And so we have to find the sensitivity between maturity and the parameters we given. So what physical properties will be changed after boil? And the density will be changed, and the inertia moment of the egg will change since that the density, since the water will permeate in the egg while albumin and yolk won't sneak out. So the boiled egg will be slightly heavier than the normal egg. So the density and the inertia moment will be changed after boil. So in the first experiment, we try to investigate how the density change and will influence the how we use the density change and to detect the egg's maturity. So we measure mass and volume before and after boiling, and then calculate density of the mass. And here's our analysis of experiment 1. We can see that the mass increase while the boiling when the boiling time increases. So we get that the sensitivity is very low. So it is not a good way to detect the maturity of the egg. So we come to the next properties about the inertial moment of the egg. During the process of the fluid rotation, fluid gathering in surrounding due to the weak centrifugal centripetal force, which causes inertia moment getting bigger. In this way, we use the rope to wrap the egg and twist it. And if we set the work as a constant, then the inertia moment will be negative proportional to the angular velocity. So in a way we measure the egg, maturity of the egg. We roll in the eggs of different maturity and measure the time it needs to roll down the slope. And since the egg is not symmetrical, so we put it in the sponge and roll it down the slope. And here's the result. You can see that the sensitivity still get very low. And since when the egg is rolled, means unboiled, is inertia moment will be the greatest. And after it was boiled well done, and its inertia moment will decrease. So due to the low sensitivity, it's still not suggested to measure the egg. So we turn to the method 3. We put the egg on the rotating plate and use tracker to analyze the rotating speed of the egg. We put the egg on the rotating plate and use a chopstick to hit it one side. And of course, and everyone knows that this kind of method have a very big error since we can't control the initial state. So still failed. So we turn to the method 4. We rotate the egg by the rope and use tracker to analyze average rotating speed of the egg. We rotate the egg every time we rotate it like 5 turns and then evaluate. So this is our analysis. We can see that the rotation velocity increased when the boiling time increased, and the sensitivity is bigger than the others. And this is our result about the maturity to the angular velocity. Yeah, it's very beautiful. Okay, and then method 5. And to here, we use the optical properties to to do the experiment. And before that, we have to talk about the absorption spectrum. It's about the ratio of the absorption of radiation within particular frequency. So in this method 5, we use halogen lamp to irradiate an egg of an unknown maturity. Through the absorption spectrum, we can analyze the maturity of the egg by wavelengths and the intensity of light. So this is our graph. And you can see that in the wavelength of 700 nanometers, you will have a very extraordinary difference between the different maturity of the egg. So the sensitivity is the biggest. And so our conclusion is that to use a halogen lamp to measure the maturity of the egg is the best way, which can get the best sensitivity. So this is our reference. Thanks for listening.
Okay, so now let's hear the report from Team B.
So it's an honor standing here, give my speech, and I'm working on problem number 15, boiled eggs. I'm Chen Mingyuan from Nanjing University. So first, let's review the problem. And I have marked the keywords on the blackboard. That is non-invasive, the cooking degree, and the sensitivity. This is the catalog of my speech. So first, it is an open question, so we need to make something clear. That is, what is the cooking process? We think cooking needs a constant heat reservoir, needs tap water and water mass, just like picture shows. As for this, we can take eggs as balls, and we have heat conduction equations. That is Formula 1. And in the spherical coordinations, we can have the transform equations, like above, and we can transform Formula 1 to Formula 2. And we take the symmetry into consideration, we can have Formula 3. So, provided that the area is infinite, we can have the Fourier expansion. That is Formula 4. And after tedious calculation, we can have Formula 5. Formula 5 shows that there is a relationship between the cooking time and the temperature of the eggs. These are the parameters. So we can build a function between the donors, that is the cooking degree, and the cooking time. So here is our definition of donors. That is under the environment of 1 atm, room temperature 30 degree centigrade. The egg was heated in a water bath at 100 centigrade. And we can build a function between the donors and the cooking time. For example, we cook 1 minute under the environment, it's called donors is 0.1. And for 8 minutes, we call donors equals to 0.8. We can also have the definition of sensitivity that S is delta measurement divided by delta donors. So this is our experiment. We can see that under different cooking time, we have huge differences of different eggs. So this is our first pre-experiment here in the chamber. It is quite interesting because the degree of eggs ripen is different and the degree of protein condensation is different. So when we knock in, the vibration mode is different and the chamber is different. The raw, the sound will be more crisp, and the more cooked, the heavier. We all know. So I have recorded the signal, the sound, and do the Fourier transformation. And please pay special attention to the lower frequency and higher frequency. We can see that as the time goes by, the higher frequency becomes lower and the lower frequency becomes higher. So we can distinguish different eggs. But we all know that it is very rough and is not precise enough. So we put forward formal ways. It is a very simple phenomenon that, when exerting angular velocity to both uncooked eggs and cooked eggs, the former can only spin in the same place, but the latter can rotate to erect. So we have our theoretical analysis to this motion, and it is a little complicated, so I make it brief. That why the egg can erect is because when it rotates, the contact point P gives a friction, and the friction gives a torque to make it erect. But why some uncooked eggs cannot erect? Because the friction cannot give enough torque, because all the energies are absorbed by the fluid inside. So we solve the Euler's kinetic equation, and when all the conditions below are satisfied, we can have the Formula 6. We know that different donors have different physical parameters, theta, and theta is relevant to the cooking time T. So we establish a function between cooking time and donors. We just need to measure the cooking time. When the eggs rotate stably, we can have this simple formula, and we can get T2. And our experiment measured the total time, T1 plus T2. These are our experimental operators. We keep the machine 1,000 round, height from the ground 1 cm, and record the total time. And here is our data and the figure. And after calculating the standard deviation, we can give a semi-quantitative maturity judgment range. We all know it cannot be very precise, so we give an interval. But to eggs between 0 to 3 minutes, the eggs cannot erect, so we just directly measure the spinning time on the ground. We can see that it also have great differences. But and we can also analyze the sensitivity. On average, the sensitivity is stable, and the sensitivity increased greatly in 46 minutes, showing a dramatic change of protein structure. And to raw eggs ranging from 0 to 3 minutes, this method seems helpless. So we need to develop another precise method to compensate for it. That is our optics method. And this is a very simple physics. That when a light comes through, some will be absorbed, some will be reflected, and some will be transmitted. And according to the absorbing law, we have formula 8. And we just measure transmittance light and original light. As to illuminations, we have talked that the eggs can absorb 700 nanometers. So these are operators. This is our phenomenon. That there are huge differences. So this is our experiment data, and we can see it is almost exponential. So here is the conclusion. Light power decreases with the increase of maturity of the egg. And after calculating the standard deviation, we can give a semi-quantitative maturity judgment range like previously. And we analyze the sensitivity. And during the boiling eggs, the downward trend of light transmittance is larger than also boiling one. That is in 0 to 3 minutes. And there are some other conclusions. So here is our conclusions. First, we give definition of cooking degree and sensitivity. Then we analyze the cooking process. And most importantly, we give two complementary methods. That in 0 to 3 downers, that the optical waves is more sensitivity. So we can use this as a primary method. And after 3 to about 10 minutes, we can have the mechanical waves. So they are complementary. And finally, we analyze the sensitivity. So this is the structure of our speech. Thank you.
Okay, now you have 2 minutes to prepare for a short question period. We start from Team B, Team A, I think. time is up, so let's have Kimby asking short questions for Kim A.
So first, I want to ask, do you have pages on your PPT? So I can't ask very fluently. And then how do you define hard? In your picture, there reviews hard. Then what is hard?
The egg was boiled in about 11 minutes, and when we opened it and we find it was well done, cooked well done. So we define the 11 minutes maturity as hard.
So that is based on experience, right?
Yes.
Okay. So can you explain briefly why the density changed?
Oh, it's because when the egg is boiling, the water will permeate into it, so the mass will increase.
And how accurate is your experiment? And I don't know how you measure the volume.
Oh, we drop into water, and
So how precise?
how precise?
Have you ever considered? So we can talk about it.
Oh, okay.
And in your experiment, there is only three data. So do you think it's a bit less?
The business, but I think I have already find the best way to.
Okay. So have you noticed that your definition of sensitivity have different dimension? You know the unit. So how do you use it?
In my experience, I just make it stay in 2 dimensions.
Okay, thank you.
Now let's proceed.
I want to ask you that in your experiment, is the frequency positive proportional to the maturity of the egg?
I don't say proportional, but it has a trend.
It has a trend. Okay. And how you measure the frequency? Because you didn't mention that.
Oh yeah, I fix the height and I drop it and making sure that it will not collapse. And I have the microphone and record the data and do the transformation in MATLAB and get figure.
Okay. Can you turn to page 19?
Okay. 19, right?
Yes. Have you fit any theory into your experiment?
Sorry, it's not a fit. It's just.
Oh, I know. I mean, did you fit and did you use any theory in this to do the error analysis?
Error analysis.
Yes.
It's just an experiment.
Oh,
Experiment.
okay. That's all.
You are done with the question? Okay. So you have 2 minutes to prepare for the discussion. let's now begin with the discussion.
Okay, so may I ask you this? When using a spectrum method, there is a superposition between the black line and the red line. How do you distinguish those two notes? I don't know the exact page.
How?
Yeah,
This one? This one?
Yeah.
You mean the red line and the
Black
black
one.
line? It is because when we boil in 3 minutes and we boil in 3 minutes and we find we can sure there's an experiment error, so we do it twice, and so there's 2 lines here.
So how do you deal with different eggs with sizes and types?
We do the experiment tens of times. We do it many times to ensure that our result is can be predictable.
So can you tell me the precision of your experiment and your analysis on the experimental errors?
Okay. In our experiment, like mango 1 and 2 and 3, you have a very big error and can hardly be analyzed, so we didn't use it. And in the method 4, I mentioned before that I use a rope I use an inertia moment to investigate it. And so to eliminate the error, we calculate the average angular velocity and then do the.
Could you show me the PPT to that part?
Like this one. The number of the rotational velocity is the average value.
Average value.
Yes. Since it will rotate like 5 times, or it will keep rotating until its velocity becomes 0. So we will calculate the average speed of the angular rotational velocity.
But we all know that eggs are like ellipse. It has long axis and short axis,
Yes.
and there are different momentum and inertia. How do you do it?
So I make the egg stand like this, so and then rotate it. So so it will decrease the error.
Oh, so in fact, we have taken this method into consideration, and we have something more precise. Like this, that a laser comes here, and we can look at another point, and we talk this parameters, and we can get the vibration, and the function is just like I have mentioned above, that is like this. So I think by using this method, I think your ways of measuring will be more precise.
Okay. Thank you. Thank you for the suggestion. And is that my turn? Okay. I want to ask you that in the first part you mentioned about the theory part. You suggest that the egg is sphere and is symmetrical, but in reality we all know that the egg isn't symmetrical and it wasn't sphere. So how do you how you do the error analysis.
I want to explain this in two ways.
Okay.
First, in this part, we just want to know that there is a function between the temperature and the cooking time, and the temperature is related to the donors. So we prove that. And in this part, we take x as false. But then we made the how can I say we made the d is heat is a heat coefficient, and the different part of the x have the different d, so we think that it can compensate.
Okay. And please turn to the frequency, the peak of the frequency and the egg maturity. Yes. It seems that next page. In this part, it seems that the graph is the peak of the frequency is symmetrical. Can you explain why? The intensity of 8 minutes.
Sorry, I don't think it's symmetrical.
In 6 minutes is a little bit like symmetrical. Like in 1.2 and 1.8.
I think it maybe can be explained as occasional. I know as by random. You know, one is lower, one is higher. There is always one place to make symmetry.
Oh.
That's this one.
Oh, okay. And which method of you use is have the best sensitivity?
From my own perspective, I think 0.03 donors, we have done the optical ways, and after 0.3 donors, we do the mechanical ways. May I ask you a question?
Okay.
So, the same question you asked me, I want to ask you.
I believe that in method 5 is the best way to detect the maturity of the egg, and I think that the 7 maturity of the egg is the best maturity to detect.
Okay.
Yeah, the time is up. Thank you both. You have 3 minutes to prepare for the concluding remarks. Starting with Team B.
my own
Okay.
report for eggs. So let's review the problem and mark out the keywords. We have familiar with it. And our competitors have written structure, problem review, experiment theory, experiment and conclusion. They have many advantages. They are affirmative, act well on stage, and giving a lively stage, per research. And he has thorough consideration on definition of donors, and he has thorough many methods to do it, and give an explicit method and give an analysis on sensitivity. However, they have some shortages. First, the theory is not complete and is not. And second, can't distinguish some eggs with different sizes. Third, we have much experimental errors and lack data. Fourth is few methods. From my own perspective, is enough. In fact, we have considered this problem more than we have shown. We have considered the mechanic ways, like the following. So sorry to not translate it into English. And these are operators. And we also complete some difficulties. We also tried some acoustic ways, but we also come up with some difficulties. And overall, this is the structure of my theory, and I think we have given a complete way of distinguish different eggs of donors. Thanks for the wonderful performance. Thank you.
Now it's Team A.
So, to the Team A, I believe that they have a very tough theory background, and then an unexpected method, like the first one, use the vibration to detect the maturity of the egg. However, like us, they don't have enough data to fit the trend of it. And like in the vibration, the way use vibration to detect the maturity of the egg, they didn't show the trend of how they didn't show the relationship very clearly between the maturity and the frequency, intensity, and I believe that in our report we have find the best way to detect the maturity of the egg using the light, since the other method like use density and inertia moment, it have very big errors to detect it. And we also do a lot of method to do the experiment, but we didn't put it on our report since the error is very, we think that it's very unuseful, so we didn't talk about it. And thanks for both tips. Thank you.
Now let's have questions from the viewers. Any questions?
I have a question for Team A. So in our way 4, you have a diagram.
Yes.
Can you show me the diagram of the maturity versus the inertial moment? Okay. So the maturity actually increases with the angular velocity linearly, right?
Yes.
Why is that? Because I think if the boiling time is long enough, the maturity should be a constant. So, but in your diagram, it just changes linearly.
Because we changed the material, we defined our maturities code, we put it in the 100-degree water and boiled for 8 minutes, we call it, and made it maturity. And in this diagram, we choose 0, 3, and 5, and 7, and 9, and 11
Okay.
to draw
So
the
the
graph.
maximum maturity in your diagram corresponds to 11 minutes.
Yes.
Okay, so for team B, can we turn to page 19? So from this diagram, what is the maximum sensitivity? I calculate the maximum sensitivity from this diagram.
You mean in fact, I do nothing on the graph, not fit it on something. And you say the maximum sensitivity. I give the answer is half 1 minute. Half 1 minute because in the next we give our intervals and we do more experiment finding that this method when the interval when it is less than half a minute, there will be some
I think you also have a sensitivity curve in some page.
yeah, that's this we have a curve because we have formula 8 and 6.
But can you show the page? So, okay, from your diagram, it seems the sensitivity is the maximum at 0 time, right? So, this is not the sensitivity.
No, it's a light intensity.
Okay,
It's
not the sensitivity. Okay.
Sensitivity is this.
Okay. At 1 minute.
Yes.
Okay, the maximum.
Okay. Question from other juror? Yes.
Yeah. For both teams, can you show your definitions of maturity or doneness and sensitivity again?
Yes. This is TV.
Okay. And what is your doneness definition? Let me read it.
My definition is under the environment of 180 at room temperature 30 degrees centigrade. The egg is heated in water bath at 100 degrees centigrade. Then we build the function between the donors and cooking time.
Or it's just time.
Only time.
What about you, May?
Mine is same as his definition.
So it's also time. Okay. And your definition of sensitivity?
It's like the slope of the.
So we are the same definition.
Yes.
Okay.
Any other question? Okay, I have a question for both teams because you both use time to define your maturity or doneness. But then according to our experience, if you cook the egg for longer than say 12 minutes, pretty much it's already done. So using your definition, then 14 minutes or 16 minutes doneness really doesn't make much difference, right? So
I think it's easy to answer because we can just set range. like the 12 is the maximum.
You just use that as your maximum scale. Okay. What about you?
Same as he says, we set the range, and if the egg is defined as a well done, and boiled well done, and then it is well done. Yeah. And I think it is not our point to find the egg was boiling in how long it boiled. It's not our point to find the minutes.
But the question actually asks you to use a non-invasive way to determine how well it is done. Right? So it does matter, right? Relevant to the question. And as for your answer, I think there's a problem that different size of egg will need different lengths of time.
So
To make it
I
right.
have a compliment.
Yeah.
Yes, because in this figure, in this figure, that's after 12 minutes, the slope is slower and equals to 0. So when you're spinning at 0, it's also 12.
Yeah, but that's for that egg. My point is that you need to use a more universal way to define your. Yeah. Okay, so let's wrap up the session and then go to the grading. Oh, by the way, I'd like to introduce the jury member. I'm Shen Zhonggao from NTNU, and this is Professor Ye Wangqi from Donghua University, and
世界高
yeah, from Beijing Normal University, and Professor Yu Huang from Nankai University. So let's first show the grades for Team A, which is Zhongxing University. Starting with me, 6, 7, 7, and 7. Okay. Now for Team B, Nanjing University. 8, 7, 8, and 8.
Thank you.
Any comments from the juror?
Yeah, I do have one comment, because here, it seems my understanding of the sensitivity of the device is different from yours. You should have only one number for the device, instead of so many points for one device. That's my understanding. But from your result, your sensitivity has so many points. What is that number? I don't see it. Okay? When you have one, for example, the figure you show with the optics. The sensitivity. Yeah, this one. That means to me that this device cannot measure anything. It has no sensitivity to this, whatever you call it. It cannot tell. That means it cannot tell the change. It's flat for a wide range.
Could you please pardon?
Not this flat, but it's different from at different values. Right? It's different here. It has some value here, but it's almost zero. Almost zero for a very wide range. Not flat, but almost zero. Right. And it means it has no sensitivity for this thing, whatever it is change.
Yes, so
Whether it's done is or something. You don't have a changing sensitivity. You have zero sensitivity for this. Or you have no definition of a sensitivity for this. That's my understanding of the sensitivity of a device. You should get only one number.
I get your point.
Yeah.
Okay. Any other quick comment?
I think the definition of sensitivity is different from yours. I think sensitivity cannot be can be a constant or not. That's what I say. So it becomes more sensitive when the boiling time is long enough.
Sometimes there's possible, but most of the device there's only one number. Right?
Okay.
And if you want to say it can change, well then again, 2 points cannot give you the sensitivity in this range. Right? If you want to tell me this range you have this sensitivity, but you have only 2 points of experiments, that number does not mean the sensitivity in this range.
Yes, I know. Okay, so let's end this session.